we're still looking at how you were supposed to answer questions in 2025. That is 0625 Cambridge igcse. And we're told that there was a heater that was placed in a room, and you can be able to see here we are having a heater, and then there are different furnitures in that room. And we're supposed to state, the student was supposed to state what are the different modes through which energy is going to be transferred through the air, throughout the air in the room. So how, in which mode was energy transferred throughout the room? So in this case, the mode of transfer was supposed to be convection. And in this convection, remember, convection is a mode of transfer of energy through fluids, and that is liquids and gases. So at the same time, students were supposed to explain how the heater warms the room. So they were supposed now to explain, now you have said it's convection. How does that happen? How does it lead to the warming of the room? So in that case, the candidates were supposed to say that when this convection heater hits the air in the lower part of the room, then the air down here will be warmed. So we are going to have warm air. When air is warmed, it expands and it becomes less dense. So warm air will rise up, and then cold air is going to come down to occupy the space that has been left. So that's why the candidate was supposed to explain how convection occurs. And in that case, we're going to say when the air at the lower part of the room is heated, it becomes less dense, then it rises up, and the cold dense air is going to come down and to occupy that space. Now, when that process keep on happening, cold air rising, cold air coming down, warm air rising, then that is going to set what we call convection currents. Yeah, so we are going to have what we call here the convection current will be set up, and this is now the process through which energy is and thermal energy is going to be transferred through the room. And also, the candidates were given another part of information that the heater was rated 2.0 kilowatts, and then it was connected to 230 volt main supply, and then the candidates were supposed to show that the current is approximately 8.7 amperes. So in that case, how were the students supposed to work out this? Now, the candidates were supposed to remember that power is equals to current times voltage, right? Current is power. Power is equals to current times voltage. Now, using this formula, we can be able to say now there from the triangle formula that current is power over voltage. Then if we substitute, we are going to get 8.695. But something that you really must remember when you are working out this question, the power was given in kilowatts. So meaning that we have to do the conversion. You change that to watts by multiplying by 1,000. So that's why you see I'm having 1,000 here in order to work out that. And now you can see if you work it, you're going to get 8.7 approximately there. Also, another part of the question that was asked in after this, remember we have gotten the current being 8.7, and then now we are supposed to state the best fuse that can be used for this heater. And what you need to remember that the fuse should be slightly above the operating current. And since it's 8.7, then the fuse that can be used here, the best fuse that can be used here is the fuse of 10 amperes, which means that this 10 ampere fuse can allow 8.7 current to flow without it blowing out. So whenever you are choosing a fuse, ensure that is a fuse that can allow the operating current to do what? To flow. Yeah. So the next topic also that showed up is the topic of waves. And under waves, we shall be focusing on light in that case, in order to understand the kind of concept that followed them. So we were supposed, one of the area that was asked here is that the students were given, of course, a question, and in that way there was a ray that was approaching, the ray that is approaching, we have air, and then we have another medium. Yeah, we have another medium there, and then below that, of course, I'm going to also indicate that there is also air there. So this ray of light is going to be moving from air. It will hit the boundary of air and that particular medium that was provided, and then it will just penetrate down into air. So in that case, I need to also mention that this angle that is provided here is actually 30 degrees, and the examiners were trying to really understand whether students understand the definition of refractive index in terms of the speed of light. So what do we call refractive index? Yeah, so what's refractive index, the definition in terms of the speed of light? So in that way, we are going first to remember how the formula we can use to find the refractive index. That's how you are to reason around this question in order for you to earn the marks. So we know that refractive index is speed of light in a vacuum divided by speed of light in the medium. So if you use this particular formula in this case, basically you will be in a position of providing what the definition of a refractive index is. So now once you've identified and you have written this particular formula that we have stated here, what is how were you supposed to structure your answer in order to fit for that particular definition? So we can say refractive index definition we can say this now is the ratio of the speed of light in a vacuum the speed of light in a medium. So in that way, if we at all really want to work out what is the refractive index of this medium air, remember refraction occurs when a wave is moving from one medium to another, yeah, And this is going to happen because the speed of light is going to be affected as it's moving from one medium to another, and the bending is going to take place at the boundary. So if it slows down, if this ray of light slows down when it gets into this medium, the soap film is going to slow down, and then it's going to bend towards the normal, and that is now what we are going to call refraction. Is a bending of a wave as it's moved from one medium to another. But also, for you to give that definition for refractive index is in terms of speed, you can talk of a speed of light in a vacuum divided by speed of light in the medium. And after mentioning that, we can also talk about show that the angle of refraction of light as enters the film is approximately 43. So we were supposed to show that that was actually part A, and then we have part B, Roman 1. We show that angle of refraction is approximately 43 degrees. How do we show that? Now, we know that the refractive index of this particular medium that was provided was given as 1.28. That was the refractive index that was given. But if you look at the angle that is given here, this is not the angle of incidence. The angle of incidence is this particular point. So since this particular tutorial, we are looking at areas that made most of the students lose marks, you realize that some students used this angle here, 30 degrees, as the angle of incidence. They did not remember that this angle of incidence is between the normal and the incident ray. So which means that they were supposed to subtract from 90, and this becomes what? 60 degrees. And now this is down here. That is what we call the angle of refraction. That means we are going to say, therefore, refractive index is equals to sine I divided by sine R. But the refractive index in this case is provided as 1.28. So which means that we can be able to say 1.28 is equals to sine 60, which is divided by what? Which is divided by the sine of R. And if you rearrange this, you will get your answer reducing to what? This is going to be, if you multiply sine R both sides and divide by 1.28, we shall have sine R is equals to sine 60 divided by 1.28. Yeah, so you'll have that, and therefore our R will be sine inverse of sine 60 over 1.28. So when you have this, you can ideally put this into the calculator so that we can be able to work out what the answer could be in this case. So if we put this in our calculator, we are going to say this is going to be shift sine inverse. Yeah, so this becomes over sine 60 over 1.28. Then we close the bracket here. So if we put that and say cosine, what's the problem here? Sine inverse. If sine inverse of sine 60, I can close these brackets, 1.28, then close here, so that becomes what? 42 points. This becomes 42.5771, which is approximately 43 degrees. And you can see now if a candidate did that in order to show that they were supposed to get that 43 degrees as it was supposed to be shown. Yeah, the defined monochromatic, student was supposed to state what is monochromatic. Monochromatic. So most students, of course, we understand that monochromatic light is light of one color. But what determines this color? Because most of the students, that's where they actually went wrong when it comes to this particular question. You are going to say this is light of a single wavelength, because the wavelength is the one that determines what? The color of a light wave. So when a light of a single wavelength is transmitted, you are going to see a specific color. Yeah, so we can say this is light of a single wavelength. This is light of a single wavelength. Basically, that's what you are supposed to say in that particular part. But I know most students must have talked about color, but idea they fail to remember that color is determined by the wavelength. So if you have many wavelengths, then it means you are going to have different colors of light. Finally, there is also the question to do with what is the frequency of light? Frequency of light. We know that light travels at the speed of 3 times 10 raised to the power 8. But at the same time, we have to remember the wave equation. F lambda is equals to the speed of light, isn't it? Right? So we were to figure it out around that line. At the same time, yeah, so in this question you can see we were given wavelength as 650 nanometer. It was provided in the question. Then we know that speed of light is 3 times 10 raised to the power 8. So meaning that if we want frequency, we are going to say speed of a wavelength, and that is going to translate to what? That is going to translate to 3.0 times 10 raised to the power 8. And this is going to be divided by 650 times 10 raised to the power negative 9. So which is basically the wavelength conversion from nanometer to meters, because nano means 10 raised to the power 9. So I'm going to substitute this to times 10 raised to the power 8 here. And then we shall have 650 times 10 raised to the power negative 9. And if you work it out here, you are going to get your answer translating to 4.6 times 10 raised to the power 14 hertz. So something that you really ought to have remembered in this question is the units for frequency. It must be given as hertz. What are the key areas that most students could have forgotten when they were answering this particular question? Is that most students could forget to convert these nanometers to meters. They end up using 650 as the frequency, and that could have costed most of the students a lot of marks. This the whole of 3 marks in this, and this is a mark that can actually change a grade boundary. See you in the next tutorial.